Problem statement 7. This is going to be another one of our situational problems, which means that we've got to make sure we read the entire thing. Let's go through and find any important information. Nikki and Justin were setting off rockets in their backyard. The rocket flew over the rooftop of Justin's house, which is 20 feet high. So it sounds like the rooftop being 20 feet high might be important. And then it landed in the front yard. Let's see, using the given conditions, create a graph of the rocket, blah, blah, blah. T is time, and D is vertical distance. Now, we've got to decide on independent and dependent. Now, remember, we many times will think about cause and effect. In this case, time and distance, you can't really have a cause or effect there. But you can say that how far up in the air does depend on the time since it was launched. So in that case, distance depends on time. So distance is dependent, and time would then be independent. I guess we could go ahead and specify vertical distance there. Now part B, label each axis. Well, our independent variable is always our x-axis. So this is time in seconds. Sorry, that's where I wrote it, time in seconds. Our dependent is our y-axis, which is our vertical distance. I'm going to turn that sideways. And it looks like I am going with feet here. So now I've got a set of labeled axes. Now let's look at our conditions here. Condition 1, the rocket cleared the roof of the house by almost 6 feet. Well, if it was 6 feet over the roof of the house, well, the height of the house now becomes important. We saw earlier that it was 20 feet high. So what that means is this thing went up about 26 feet in the air. Now, I can't plot that yet because I don't know what time that happened. We'll have to come back to that in a minute. It took 1.5 seconds for it to reach a height of approximately 15 feet. So let's go to 1.5 seconds and then go up to 15 and go ahead and plot that point. Now, condition 3, the rocket was in the air for 3 seconds. Well, for 6 seconds. If it's in the air for 6 seconds, then that means it's going to hit the ground at 6 seconds. And condition 4, the rocket was launched from the ground. Well, that means at time 0 when it started, it was at ground level. Now, we still haven't used that 26 feet. We got to get that vertex in there somehow. If I can see that we go from 0 to 6, well, my axis of symmetry has to happen exactly halfway in the middle, which means it has to happen here at 3. So my axis of symmetry is a vertical line at 3. So I can use that to then come up and plot my point 26. Now, those are my 4 conditions. From there, I can go ahead and use my symmetry property to take this 15 and reflect it over. I can count 1, 2, 3 grid lines from the axis, so I can count 1, 2, 3 grid lines from that axis and go there as well. So there's the basic flight of my rocket. Now, part D, what ordered pair represents the y-intercept? Well, y-intercept is 0, 0. What does the y-intercept mean? Well, at time 0, it was 0 feet in the air, which sounds like the rocket is launched from the ground. Which I really like that answer because it exactly fits word for word with number 4. And when will the rocket be approximately 20 feet high? Well, go to 20 and I look across, it'll happen at about 2 seconds and at about 4 seconds. So I'll put 2 and 4 seconds.